Okay, we've got a question that's worth recording. Come on up, don't be shy. They'll get to know you guys. All right, so we've got, for the first laboratory, we've got to have a lot of LEDs. And so from past projects, the students here have found some LEDs that are hooked up. They've got one terminal hooked up to a common wire, and then they've got a bunch of other terminals. Each one has a resistor on it. And the question is, well, these should be right? I mean, these resistors should be sized for this LED. Now, let's have a discussion for the whole class. What's right or wrong about that?
You're assuming you're not double checking.
Yeah.
Okay, yeah, but what could go wrong?
You could burn up the LED.
We could. Go ahead.
You put the wrong voltage to it.
Exactly. We don't know what electric potential was originally intended with this resistor. If the electric potential goes up, what's going to happen to the current through the resistor? It's going to go up. V equals IR, right?
Too high and blow it.
Right, so we might get too much current. So we don't know. You know, we happen to have the man who built these here. So what voltage did you intend these to work on?
5, I believe.
5 volts. So they would probably work, okay? But we should check.
I would take a meter across the resistor to see what the.
Yeah, we can do that. We can also read the color code. I don't know if you can see this on the camera, but the color code on the resistor is,
Got brown.
Is it red?
it looks like red, black, 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 brown, but I can't tell which way to read it. So this is an odd resistor because I don't see any,
They're 200s.
they're 200s? That doesn't make sense. I don't know why it's listed, it's drawn that way, but okay, they're 200s.
Yeah.
A ton of those with a bunch of LEDs from Alibaba or something.
Yeah,
And
so
they
they're-
say 200s.
They're not really marked standard way. Okay, so they're 200. So we could put a meter across this and measure 200 ohms, and you would have been lucky, right? It would have worked. It's 5 volts. So if it's 200 ohms at 5 volts, how much current at most could go through these LEDs? How would we do that? Something you got to get used to doing. V equals IR.
Yeah, you got your voltage and you divide it by resistance.
Exactly. So 5 volts divided by 200 ohms.
1.25 amps,
So
25 milliamps.
25 milliamps, very good. Now that's at the upper end, right? There's actually going to be a voltage drop across this LED, so there's going to be less current going through it. So it's probably close to 20 milliamps or something like that, once you got the voltage drop across the LED. Because it's probably more like 4 volts divided by 200, which would, I think if my math is right, that would be 20, wouldn't it?
Yeah.
So probably that's what you'll end up with. And there's something else, now that the camera's on, I wanted to mention. We've got to make sure the Arduino IDE is installed in the lab in Anderson, but I sent Matt a message about that. I'll think of it as soon as I turn off the camera. But that's okay, I'll turn the camera back on at that point.